All right, let's move on to problem number 11. The two legs of a right triangle measure 5 and 12. Which of the following is true about the numerical values of its area and perimeter? Is it A, they are equal, B, greater than, or C, less than? Which of these do you think is correct? So let's reveal the solution now in 3, 2, and 1. So when we speak about the two legs of a right triangle, these are the two sides that make your right angle. And so by the Pythagorean theorem, we could see that 5 squared plus 12 squared equals x squared. By the way, I let x to be the length of AC here. And from such, you have 25 plus 144 equals x squared. 169 equals x squared. Let's take the positive value of x by taking the square root. We get 13 equals x here. So in this case, AC here has to be 13. Now, since we were able to compute for the remaining side, we can now identify the area and the perimeter. The perimeter in this case. But for the meantime, for the area, it's base times height divided by 2. So we have 5 times 12 divided by 2. That's 60 divided by 2, or 30 square units for this case. And to get the perimeter, remember, perimeter is simply the sum of all the interior angles of a polygon. So getting the sum of 5, 12, and 13, you could also see that it's 30 units. And we could see that numerically speaking, regardless if it's units or square units, you could see that they are both 30 here. Hence, we could say that area is equal to perimeter numerically speaking. Letter A is the correct answer here. All right. Let's move on to item number 12. A circle has a circumference of 20 pi cm. What is the largest area of a triangle? What is the largest area of a triangle inscribed in it if one of its sides is the diameter of the circle? So in this case, it would actually look like this. So this is the diameter. And remember that circumference is equal to 2 pi r, right? And since the circumference is 20 pi here for this case, based on our problem, so 20 pi is equal to 2 pi r. And you could see if we divide both sides by 2 pi, then you could see that your radius is 10 units, or it follows also that your diameter is 20. Now, since your diameter is 20, so here, no, this is your diameter here. That's why CD has to be 20 units long. But remember, how long should the height be? Because it could be, it's also like this. It could also be like this. There's so many choices for the height here. But remember, since this is a diameter, then the longest segment connecting a point, or connecting the center, the longest segment that you could draw here is in the longest height possible, is the one that connects the center and a point on the circle, and that they are perpendicular, and that the radius that you draw should be perpendicular with your diameter. Hence, the height here will be your radius, or 10 units. Hence, you could achieve the maximum area when height is 10, and that the area of a triangle is base times height divided by 2. And thus, you have 20 as your base, times 10 as your height divided by 2, and that gives you 100 centimeters squared. I hope you got this answer as well. If you do, congratulations, but if not, do your best for the next ones. Number 13. In triangle ABC, let X be a point on segment BC such that the ratio of BX to XC is 3:5. Find the ratio of the area of triangle ACX to that of triangle ABC. So feel free to pause and solve if you wish. And I will reveal the solution in 3, 2, and 1. So from the illustration, this is how the figure looks like. So X is a point here, that's such that the ratio of BX to XC is 3:5. You could actually represent here with say 3y is to 5y, but for now, let's say I will treat them as 3 and 5 for now. So if that's 3 and 5, this is 3 units, BX is 3 units, XC is 5 units, so BC is 3 plus 5 or 8 units in all. And remember, if two triangles have equal heights, in this case, if I draw this segment, which is perpendicular to BC, then you could see that these two triangles, ABX and ACX, in fact, share the same height. Then the ratio of their areas is equal to the ratio of their bases. Thus, the ratio of the area of what? Of your ACX to that of ABC. Remember, ACX is 5, base 5. ABC has a base of 8. That's why since they share the same height as well, then the ratio of their areas is the ratio of their bases, which is 5:8, or 5/8. Okay, so far so good. Now let's move on to the next one. What is the maximum area of a rectangle whose perimeter is 80 meters? So more often than not, others approach this using calculus, others approach this using quadratic equations. But for now, we will stick with an elementary approach. And remember that among all the rectangles having equal perimeters, then it attains its maximum area if it is a square. And this entails that all 4 sides are equal in terms of length. Hence, each side of your square or rectangle is 80 meters over 4, which is 20 meters. And the maximum area is, remember, side squared, because if it's a square, then its area is side squared. That's 20 meters squared equals 400 meters squared. Don't get me wrong. Remember as well that all squares are rectangles. Okay? That's why it still fits the definition. Number 15. A rectangular box with positive integer dimensions, meaning in this case, let's represent the length as x, width as y, and height as z, have a volume of 18 centimeters cubed. How many ordered triples, x, y, z, are there in all? So for this case, we have to remember that volume of a rectangular box is length times width times height. So given this one, we have x, y, z, their product of x, y, and z is 18. But here are some triples whose product is 18. You could have 1, 1, 18. And if you have 1, 1, 18, there are 3 permutations for such. How come I took permutations? Because order matters in this case. When we speak about permutation, it is the arrangement of an n number of a certain finite number of objects where order is important. So in this case, you have 1. Let's note all three if you wish. 1, 1, 18. You could have 1, 18, 1. You could have 18, 1, 1. Those are the three of them. You also have 1, 2, and 9 because you could see 1 times 2 times 9 is 18. And if you will write everything, there are 6 possible permutations or arrangements. You could have 129, 192, 219, 291, 912, 921. Those are all the 6. And you could also have 136. And there are 6 arrangements for such. You could also have 233. And there are 3 arrangements for 233. We have 233 itself, 323, or 332. And if you could notice, these are the only possibilities because we are talking about integers. And there are no more integers that would satisfy this, having a product of 18 cm3. So these are all the possibilities, and we have to add all of them. That's 3 plus 6 plus 6 plus 3. That gives you 18 ordered triples in all. If you got 18, congratulations. 16. How long is Ln in this case? You could see that you have triangle LMN. L is 30 degrees, M is 105 degrees, and the length of MN is 4 square root of 2 units long. Now, for this case, there are many ways of doing this. What others do is that from this point here, they draw a line perpendicular to Ln, so that this will be 90 degrees, so this will be 60, this will be 45, 90. So you will have a 30, 60, 90 triangle and a 45, 45, 90 triangle. And for this case, however, I will not be using that. I will be using trigonometry for this case. So how long is Ln? So you could see, we could in fact use what we call the law of sines, because you could see we have here side, angle, angle. And if that's the case, we could actually utilize what we call the law of sines. That is, by the law of sines, if you take, for example, what does the law of sines mean? So that is the ratio of a side and the sine of its opposite angle is of any triangle is of in this case of a single triangle is equal to the ratio of another side all over the sine of its opposite angle, and so on. So in this case, or if you took the reciprocal, no problem, as long as if it's side on top, so it's side all throughout. But if sine of an angle is on top, then all throughout it's sine of all the angle all throughout as well. So in here, I have Ln, this side over sine 105 degrees, all over 4 square root of 2 divided by the sine of its opposite angle. So we have sine 30 degrees. And to solve for Ln, we will multiply both sides by sine 105 degrees, and that Ln is equal to 4 square root of 2 times the sine of 105 degrees all over of sine 30 degrees. If you are familiar now, I hope you are familiar, sine 30 degrees is 1/2. However, we still need to look for the value of sine 105 degrees. And remember that we have this formula in trigonometry. If you have the sine of the sum of two angles, A plus B, that's equal to the sine A times cosine B plus cosine A times sine B. So here, we know that 105 is equal to 60 plus 45. We utilize 60 and 45 because they are special angles, and that it is known their sines or cosines of 60 and 45 are known and are familiar with many, I hope. And with such, you have sine 105 degrees. It's sine of 60 plus 45, which is sine 60 times cosine 45 plus cosine 60 degrees times sine 45 degrees. Sine 60 is square root of 3 over 2. Cosine 45 is square root of 2 over 2. Plus cosine 60 degrees is 1/2. Sine 45 degrees is square root of 2 over 2. And if you simplify this, you could actually see that their common denominator is 4. And thus, sine 105 is square root of 6 plus square root of 2 all over 4. Okay? So, since we have now the value of sine 105 degrees, we can now substitute it to the given form earlier. So ln is 4 square root of 2 times square root of 6 plus square root of 2 all over 4 times, all over 1/2. You could see that the 4 divided by 4 here becomes a 1. And if you divide by 1/2, you just simply multiply by 2 to the expression in the numerator. Hence, we have ln equals the 2 square root of 2 times square root of 6 plus square root of 2. If you multiply that, that becomes 2 square root of 12 plus 2 square root of 2. That's by distributive property of multiplication over addition. And 12 is square root of 4 times 3, which is 2 square root of 3. And 2 square root of 3 times 2 is 4 square root of 3 plus 2 times 2, which is 4. Hence, if you answered 4 square root of 3 plus 4 or 4 plus 4 square root of 3, you got it correctly as well. Congratulations. Number 17. The ratio of the areas of two squares is 5:4. What is the ratio of the lengths of their corresponding diagonals? So for this purpose, maybe many of you will be solving for the exact lengths of the diagonals. You don't need to do that. Why? The ratio of the areas of the two squares is 5:4. Then, remember, the ratios of the areas of two squares is equal to the square of the ratios of their corresponding sides or even their diagonals. That is why the ratio of d sub 1 to d sub 2 is equal to d sub 1 represents the area, the diagonal of a square with area of 5, and d sub 2 squared represents the area of a square with represents the area of a square with area of 4 units here in this case. Now, so the ratio of d sub 1 squared to d sub 2 squared is 5:4, and taking the square root, the positive square root of both sides, we could see that d sub 1 to d sub 2 is square root of 5 is 2, square root of 4, and square root of 4 is 2, right? Therefore, the correct answer here is square root of 5 is 2. I hope you got it. Okay? So you see, it does not require a long process as long as we know the theorems associated with them. But if not, feel free to do the long method and you can verify this on your own. Number 18. How many non-overlapping squares are there in figure 99? Take a look. In figure 0, we have that. Figure 1, figure 2, figure 3, and so on. What do you think? Pause the video if you wish, and if you are ready, I will reveal the answer in 3, 2, and 1. So you could see that in figure 0, if we are just keen enough, we could see there's 1 square, but 1 square in figure 0. But 1 is equal to 0 squared plus 1 squared. If you are in figure 1, figure 1 has 5 squares, right? This one, we have 1, 2, 3, 4, 5. But if you could see 5, that's 1 squared plus 2 squared equals 5 squares in figure 1. If you are in figure 2, if you count individually, there are 13 of them. But you could see that 13, that in figure 2, that's 2 squared plus 3 squared. And in figure 3, there are 3 squared plus 4 squared equals 25. So how many squares do you think are there in figure n? That would be, if it's 3 squared plus the square of the next integer. So in figure n, there are n squared plus n plus 1 quantity squared squares in figure n. So in this case, in figure 99, that would be 99 squared plus 100 squares, which is 19,801 squares in figure 99. With that, I hope you got this. You see, we just made use of a pattern for this case. So it's important to know the pattern. Problem 19. The 3 sides of a triangle are 11, 15, and 18. Find its area in square units. You could actually see that this one is not a right triangle, but there are many ways of getting the area. And one way is by utilizing what we call Heron's formula. That is, A, which represents area, is equal to the square root of the quantity S times S minus A times S minus B times S minus C, where S is what you call the semi-perimeter of your triangle. That is, A plus B plus C all over 2. So let's compute for the semi-perimeter of your triangle. So you add the 3 sides, divide by 2. 11 plus 15 plus 18 divided by 2 is 22. So S is 22, and A, B, and C are the 3 sides. So by substitution, that's A equals the square root of quantity 22 times 22 minus 11 times 22 minus 15 times 22 minus 18. And this simplifies to 2 times here. This is 22, but I expressed 22 as 2 times 11. For 22 minus 11 here, that's 11. 22 minus 15 is 7. And 22 minus 18 in this case is what? Is 4, right? 22 minus 18 is 4. And so with such, you could see that we have here 11 squared. So the square root is 11. But the square root of 4 here is 2. So we have 11 times 2. And what is left here is 2 times 7 in the radicand. And hence, this could still be simplified into what? We could simplify this as 11 times 2 is 22. So this should be 22 here. And 2 times 7 is 14. So 22 square root of 14 square units as the answers here. So we were able to see some corrections along the way in the PowerPoint presentation, and it's a good thing that we are able to correct them as well. And I hope you got this answer correctly. Let's have number 20. circle D is tangent to the three sides of your triangle ABC at points F, G, and H as shown. If AB is 16, BC is 13, and CA is 25, how long is AH? Okay, please solve this problem. Let's see if you got them correctly. Now, from here, remember this. It is in fact a theorem. Like example, if you consider point A, if you remember, these are all tangents. AF is a tangent, AH is a tangent, CH, CG, BG, and BF are all tangents to circle B. And we have to remember a certain theorem that states, from a certain external point, there are two tangents that could be associated with a certain circle. So that's why for point A, I have here the two tangents, AH and AF. And what is good about these two tangent segments with respect to this one external point here is that the two tangent segments drawn are in fact congruent with one another. That's why AH and AF are equal to X in this representation. BG and BF are also both equal to Y in this presentation. And CG and CH are both equal to Z here. And remember, based on the problem, it says here that AB is 16. That's why AB, where's AB? AB is X plus Y, which is 16. BC is 13. That's why Y plus Z is 13. And here, for CA, that's Z plus X equals 25. And what we will do next is that we will employ what we call addition property of equality. So the sum of all the terms on the left-hand side is equal to the sum of all the terms on the right-hand side. So for the left side, you could see there are two x's, right? Two y's and two z's. That's why their sum is 2x plus 2y plus 2z equals 16 plus 13 plus 25, which is 54. And you could see that we could divide each term by 2, and or dividing both sides of the equation, we get x plus y plus z equals 27. But remember, we are looking for the value of, or the length of AH. And AH here is x. So we will solve for the value of x. And if you could see, if we know the value of y plus z, we could know the value of x. But y plus z, based on the representation here, is 13, right? Hence, substituting y plus z with 13, you have x plus 13 equals 27, and that gives you the length of AH or x, which is 14. So if you answered 14, congratulations, you got it right. Okay,